What are some of the issues you're facing with clustering? What type of clustering are you looking into? What's complete? Yeah, I can do that, but it's in here. Like, you have a question, of course, on recommender systems. You have it in 2022, and you also have it in 2023. So if you go through your exam paper, were you able to do this question yourself, or did you face any difficulties in this question? That's clustering. Someone said they had a question clustering. We could bring that up. So this is recommender systems. So what is it that you're facing difficulties with in recommender systems? Like I said, whatever question you will ask, I've already given you the solutions to these exam papers. So the steps of targeting how to go about answering these questions are already listed. Unless specifically you don't understand a specific thing, then I am able to address that. But to go over the entire concept again, no, because we've already done this in our lectures. We've done it during our lecture revisions where we've done applications. So you have to refer back to those recordings. Now, this is for 2022, but also if you go through 2023, you will see also there is a question on recommender systems, and you'll see that it has a solutions for it as well. So you just need to follow that. No, none of the formulas will be provided. You will not get any particular formula at all. So you have to know your formulas. So let's start with what you need to do. Like I said, 2023 and 2022 will be a good solid foundation to start off with. And as you face difficulties, you want to reflect back on your tutorials, followed by your lecture notes, followed by lecture application recording. So that's where we practiced an example. That's what you want to go through. Okay, so let's start with the hints. So someone had a question on clustering. Please bring that up for me too. What sort of question on clustering? You will see if you look at your past exam papers that are posted on Moodle, you have questions in regards to clustering. So I've focused on agglomerative clustering. And if we go through our notes precisely, I believe clustering is on top. All right, so you'll see one paper has it on top. So you need to go through this clustering as well. And if you go through your tutorials, you will see also clustering is explained in depth in the tutorial questions as well. So go through it as well. Now, just to be more precise with what we have mentioned, you will see in here I have said clustering, K-neighbor, hierarchical clustering, and dendrogram. Problem and theory. So that's the two I'm testing you on. I'm testing you on hierarchical clustering, and I expect you to know how to go about drawing a dendrogram. And of course, you might encounter some theory-based questions in regards to clustering as well. Okay, so just focus on what has been listed here. This is directly related to the nature of your questions. So let's start. First, you have decision trees. Now, if you're looking at 2022 or 2023 paper, if we look at decision trees generally, tell me what are some of the issues you face with decision trees? You will see in here you have a question and your decision tree is being constructed. And based on these constructions, that is asking you to make a prediction. So using whatever is depicted in the image, you're supposed to make a prediction for these three instances. Now, based on these predictions, it also goes further to ask you justify your predictions. Why, for example, for Alex, it was a train, for example. So, of course, you justify based on the rules that are derived from the decision tree. So it's listed in there. Moving forward, they had, I think, another question where they had a set of data, and based on the set of data, they had to determine what was the expected answer and what was the predicted answer. And of course, they are doing this to establish a confusion matrix, where in the confusion matrix, they will have to calculate the accuracy, the misclassification rate or the error rate, and so forth. So that's what the follow-up of this question was. And you can see in here, they also had to calculate information gain. This is in 2022. Let's go to 2023. 2023, if you look at it carefully, you will notice that also you are given a decision tree, and the diagram of the decision tree is given to you. Again, you are supposed to make some sort of a prediction based on this diagram. And then based on the prediction, it says construct a confusion matrix. So this was the expected output, but this was what was predicted based on the tree that was provided in the question. And you were supposed to come up with a confusion matrix that depicts the errors, the total number of errors, etc. And then there was a set of questions that followed. So then calculate accuracy, etc., maybe precisions, error rate, and so forth. So all that is part and parcel of that question. Now, I have tested you on confusion matrix. In these previous semesters or these particular years, they were not tested on confusion matrix. So I have not mentioned, as you can see in here, maybe you will have theoretical questions in regards to your confusion matrix. But in here, when you see that the concept of decision trees, it just says decision tree classifier problem and theory, generally. If you go through this, you will not see confusion matrix in here because I've already tested you on it. So there is no need for me to retest you on it. So I'm not testing you on that again. You will also see in 2023, also there was a question related to information gain. So towards the end, no, there was none in regards to information gain. It was just more focused towards your confusion matrix and how to make predictions from a decision tree. Now, of course, you have to know all the different aspects that are related to decision tree. So potentially, as you can see in these two exam papers, you were given a diagram for a decision tree, but sometimes you're not given a diagram. Sometimes things would work a bit differently. Sometimes you are given a table instead of a diagram. And then you are asked to create a decision tree. And we have been taught carefully that we cannot just blindfolded create a decision tree because we need to know what is our root element. And of course, to establish a root element, I will need to calculate the information gain for each and every attribute. But then again, that's not practical in a final exam. You cannot go about calculating information gain for each and every attribute. That might be practical in real life, but not during an examination period. So the idea behind it is you will be given questions in regards to decision trees. You need to utilize the knowledge gained from understanding the concept of decision tree and then applying it carefully to answer your questions. Now, to simplify things, I don't think I've asked about confusion matrix. So you do not have a question in regards to confusion matrix. And also I have not asked you to calculate information gain. There's ratio gain, there's information gain. Of course, information gain to calculate, you need to know how to calculate entropy as well. However, that does not mean that there's no theory-based questions in regards to those concepts. No, you need to understand both the theory and the application, okay? So that's very important. That's about decision trees. Now, in decision trees, you will see, according to it says data pre-processing as well. So you might see that potentially that these two concepts might be interconnected in a given question. So I'm asking you not only theoretical questions about data pre-processing generally. So of course you need to know what is data pre-processing. You need to know the advantages of data pre-processing, disadvantages of data pre-processing. When do I apply data pre-processing? Is it that every time I'm given a data set, do I really need to pre-process it? When is it that I don't pre-process a data? So I need to keep track of all these, and this is based on your experience from this course, of course. You will be given application. So maybe I'm giving you a raw data set and I'm asking you to pre-process it for me. So how do you go about pre-processing, and what are the steps that you will take to pre-process this raw set of data, for example? Okay. So again, when it comes to pre-processing, you need to focus on the theoretical concepts of data pre-processing, which is reflected, of course, in your notes, plus the application of it as well, which you have experienced a bit in your short test 1 and in your MST as well. So you need to go through that. Okay, what else? Right, then you have naive Bayesian classifier, as you can see in here. So again, you want to ask yourself, what is naive Bayesian classifier? Let's go forth through the theory. When can I use it on a data set? When can I not use it on a data set? What are the advantages of it? What is the disadvantages of it? Is there any assumptions made for naive Bayesian classification? When I am working with naive Bayesian classifier, is there any assumption that you need to make? Yes, we always make an assumptions. What is the assumption made on our data set? We always say that all the attributes are considered to be independent of each other in relation or in respect to our outcome, which is our class label. So naive Bayesian classifier works with the condition or with the assumptions that the attributes are independent of the outcome class. That's very important. But then again, that's not really realistic in real life, right? So again, understanding these concepts, then if you are presented with a data set, you need to study your data set carefully, see whether it could be applicable to it or not. And then you have the what are some problems we face with naive Bayesian classification? We don't want biasness. So what does that mean? That means what happens if I'm getting one or both the probabilities to be zero? What do I do there? What do you people do? You need to handle it. So how do you handle it? Students, are you with me or not? Yes, we handle it through Laplace smoothing. There are other methods out there that could be implemented or utilized, but we have learned through Laplace. And I've showcased an example in one of the lectures. So you want to go back through that example and read through it carefully as well. Okay, so that's in regards to your naive Bayesian classification. So again, when I say theory, I mean every aspect of the concept has to be well understood by you. Then and only then you will be able to apply it. Else you will fail for the during the application part. Okay, then what do you have next? You have, okay, it says here distance measures, so it does not specify what. So what are the distance measures that you have? Now, of course, if it does not specify in a question, then we know that it's Euclidean by default, unless stated carefully by the question, right? So what are the different types of distance measures that you have learned? Students, what are the different type of distances you have learned in the course? Manhattan, Minkowski, what else? Euclidean, what else? Yes, what else? Hamming distance, which you have been tested on in your MST as well. Yes, your Hamming distance. All right. So these are some of the distance concepts or measures that you have actually worked with during this course. So you're expected to know all these types of distances, right? And then you are targeted. It's very important for you to know distances that can be applied to different concepts in data mining. And one of the concepts that you tend to apply distances is KNN. So when you are looking at KNN, if the question does not specify, then you work with Euclidean. But if the question specifies, then you have to work with the type of distance that is listed in the question itself. And if you again go through past exam papers, for example, if you go 2023 and you look at the question in relation to KNN, which is this one, for example, So you will see in here that you have a data set, and this particular data set contains two features only, and it also has an output, as you can see. And the output is colors, and I have blue, red as the two binary outputs that is reflected in here. So it's a binary output. And according to this given question, it asks you that for a given feature, this is a new feature, it has the first attribute of a value of 6 and the second attribute to be of a value of 5. It wants you to classify it using KNN with a value of 5, and it asks you specifically to work with Euclidean distance. And of course, you have an illustration of how to go about it, so it's straightforward. It's not difficult, so it's straightforward. The variations in here is, of course, your data set. What could you encounter differently? So if I'm a student and I'm studying and I'm going through this paper, I first notice that this data set only has two attributes. That's the first thing I notice. I also notice that my output is binary. Okay, let's take a look at 2022. So 2022, did it have a KNN question? And if it did have a KNN question, let's just look at the data set. Going through the KNN data set, I can see that again, I have two attributes, x1 and x2 as well. And I also notice that I have a binary output as well. So it's just plus, minus, plus, minus, plus, minus, plus, minus. Okay, so of course I will attempt both these questions and hopefully you do not encounter any issues and you are all good and smooth with it. Then what you would want to do, or what I would do as a student, is I will modify the features. Can I have, for example, 3? What happens if I have 3 features? How will that have an impact in my calculation? What about if I'm working with a multi-class? That means it's not binary, it's above binary, so it's 3 or 4 output. What happens then? Okay, so the question says Euclidean distance, but we know that there is Manhattan, there is Minkowski. So now the same question, let's attempt it with a different distance measure. So that's how you tend to revise things to help you prepare for any given question. So you tackle the question at hand and then you start modifying the question while you are revising it. That's the best strategy for learning. So, like I said, when you look at your data set, attempt it for what it is or what it is asking you to do. This is in 2023 and 2022. And then go a step further in your revision and start playing with your data set, change things in there, and then make an attempt and see, are you able to answer that or are you facing difficulties in that? So that's how you will learn. That's how I used to study when I was a student. I recommend you do the same. In fact, I used to create new questions again, but not the same question. It defeats the purpose. You're just wasting your time. You want to create new questions where it's different. So you could tackle it from a different angle, right? So that's KNN. Okay, what is so good about KNN classifiers? Or what is so bad about that? That means we have to consider what is it, what sort of data is suited for KNN. This is all theory, you need to go back and reflect on that. We have to consider, does it matter if my K value is large? Does it matter if my K value is small? What's the difference when my K value, for example, in here you can see that the K is 5. What happens if I keep the question as is and I use K is equal to 1? What happens if I keep the question as is and I use my K value to be 10? What happens? Is there a dramatic change in the prediction value? Why? Why is this happening? So you need to ask yourself this type of questions. And again, this is a reflection of the theory, right? So you have to go back, look at the theory. I've already taught you that there is a variation. They say that the best value for K should range between 3 and 7. So too large is not considered to be good. Too small is also not considered to be good. But the question is why? Why is it not considered to be good? So why is it not considered to be good is what you need to, of course, know. Right? So it falls under the concept of course, over-smoothing, overfitting, underfitting, and those concepts. So you want to reflect back on those concepts as well. That's important. So that's KNN. And then what do you have next? In here you have hierarchical clustering. Oof, okay, coming down to hierarchical clustering. Right, for hierarchical clustering, I'll just go down and then I'll come back up. Okay, so we have learned different types or different clustering techniques, of course. But in here specifically, I'm telling you that I'm testing you on hierarchical clustering and I'm expecting you to know how to draw a dendrogram. That's what I'm expecting you to do. I'm also testing you hierarchical clustering. Okay. You also need to know your k-mean, k-nearest neighbor, k-mean as well. K-mean clustering is also important. I'll give you that as a hint, so please go through it as well. You need to know how to go about establishing your distance matrix. We talked about that. And of course, when you're creating your distance matrix, focus on either the upper part or the lower part. So you'll use the diagonal as a guidance for you. You don't need to come up with both, of course. Now, for simplicity, you will see that I have what I've done is I'm not expecting you to create your distance matrix from scratch. I have given you partially incomplete and you are supposed to complete the ones that are blank, okay? But you, of course, you need to know how to go about calculating your distance matrix. That's very important as well. It's very important for you to know how to go about creating your dendrogram, of course, agglomerative. When we talked about agglomerative algorithms, if you recall, we had single link, we had complete link. So the different linkage that we talked about, you need to know how to apply that as well. That's another hint for you. And of course, then finally go about drawing your diagrams. So for clustering, you're not only looking at hierarchical clustering and dendrogram, but you're also looking at k-mean clustering as well, which is also covered in your notes. So consider going through both your k-mean clustering and your hierarchical clustering. You have divisive and you have agglomerative. So the focus is more on agglomerative, okay? So go through that, go through the notes, go through the tutorial questions. That will help you as well. And if you go through your final exam papers, you will see that you also have questions in relation to that. So in here you have a clustering question as well. And this is an agglomerative with complete link. You can see that. Attempt that question and see how it goes for you and then to draw the dendrogram. So expect a question similar in nature. You need to know how to go about doing that. In here, if we look at our classification, Bayesian. Okay, that's regression. We'll get to regression in a bit. But you can see in here as well. So you are given 5 objects and they have the following features, and it asks you to apply hierarchical agglomerative algorithm. So again, hierarchical clustering is something that you will be tested on. So just be mindful of that. You can see in here that the link is different. It's a single link. So consider going through the different measures with different links. Okay, that's recommended system. So that's clustering. Someone had a question in regards to clustering. What's your specific question? Please list it. My hint, please go through k-mean and please go through hierarchical clustering. Hierarchical clustering, we have agglomerative and we have divisive. So go through both. The focus more on agglomerative, but go through both. That's important. Okay. Go through your distance matrix, how to go about establishing it using the different linkage that we have learned. There were 3 different types of linkage that we have covered in this course. So you need to know all those three different linkages. Very important. All right. Next, what do we have? You have associative rule mining. So for associative rule mining, let's see what hints can I give you. Again, you have to go through 2022 and 2023 minimum and through the tutorial questions that are in relation to associative rule mining, and of course through the notes, because that's where you will get the theory aspects of it. That's very important for you. So you will definitely have theoretical questions. So first you want to ask yourself, what are associative rule? Why are they considered to be critical given the fact that we have or we deal with large sets of data? How does it come into effect? What is its advantages, disadvantages? Look into that. What are some other terminologies that are associated with association rule mining? Give me some other terminologies that we have learned. Of course, when you're working with association rule mining, you have to know your a priori algorithm. You have to know support. You have to know confidence. That's very important. You will be working with a specified value for support and confidence. So you need to understand those very carefully. What are some of the other concepts that we have learned? We've learned what is a frequent item set. What do you understand by that, right? So how do I know that this is a frequent item set? And apart from, of course, the application of it, you also need to know how to generate rules. And you generate a rule based on minimum threshold of a given confidence percentage value. So you need to know how to generate rules, which of the rules are considered to be okay or strong rules, and which of the rules will be discarded or considered not to be okay rules. So that's also very important in association mining. So again, if you reflect back onto 2023 and we look at association rule mining, so you can see in here you have a transactional data set, and they're asking you in order to create creative book handles, apply a priori algorithm, and they're giving you a support value, and they're giving you, of course, a confidence value as well. And the first is asking you to identify a set of books with minimum support. So that's the first that it's being asked of you. And the second part, they're asking you to generate most likely the rules as well. From the above data set, we'll calculate confidence for the combination and rules derived and derive the rules. So as you can see. So you expected, of course, to know your a priori algorithm. You expected to know how to go about calculate driving rules. And of course, when you're driving your rules, you need to work with the threshold for the confidence. And when knowing which transactions are critical or important, you have to work with the threshold for your support value as well. And the theory behind it. Like I said, what is it? When can I use it? Why is it considered to be important? So again, looking to advantages, disadvantages. What are some of the terminologies you have learned? You've learned what is a frequent item set. We've learned that. We've learned what is a closed frequent item set. What is that? So look into that as well. So look into all the terminologies that are affiliated with association mining. Okay. And usually you will see that these are quite applicable to online data. So e-commerce, where you have transactions occurring online, because we have vast amount of data that we can capture. So that's where we tend to apply association rule mining. And of course, for marketing strategies to enhance profits and to enhance product placements. So we've talked about all this in the lectures. You want to reflect back on that. Then you have classification, problem and theory as well. So we have to go back to our classifications. This is part of course, part and parcel of your also tree classifiers. So take a look at the theory concepts of classifiers as well. Classification. Okay. Then you have regression. So regression, if you go back through your 2022, this association rule mining as well, go through this example as well. You will see in here you have some theory questions as well. If we go through our, where was it? It was regression. So if we go through regression, you will see that linear regression is the application. So you see that you will have questions similar to this in nature. And I've formulated this table during our lecture revisions as well. So it's just a guide to help you answer the question easier. So you could apply these values to your formula, make a prediction. You will have theory questions in regards to regression. So when you are studying your regression, you have 15 types of regressions. You need to go through them, understand them, analyze its application. So you will be given scenarios as such, and these scenarios will be reflecting some sort of a data and some sort of a prediction that needs to occur on this data. And your job would be to be able to establish what type of regression is well suited for this scenario and a justification of why, for example. In this example, you'll see as such, it says a research team at the University of the South Pacific wants to determine whether or not students will be progressing with their learning remotely based on a current pandemic. So you can see that the output is whether or not it's binary. There are two possible outputs, progressing or not progressing. Those are the two outputs. And that's why we say it's a binary logistic regression. Why is it binary logistic? Because the output is considered to be true value. So that's what I mean. You need to go through those different types of regressions. We've done some examples as well during our lecture revisions, and we have encountered few types as well. So of course, I won't be asking you for the non-common types. You will be encountering the common types that are commonly practiced based on the given scenario or the data set. So you might be given scenarios or you might be given a data set, and then based on that data set, it will ask you what regression technique is best suited for this given data set or for this given scenario. So go through this exam papers. This will help you a lot. Same with 2023. Along, you should know why we are working, for example, why is it a binary? So you should know the justification for your answer. Well, it falls under pre-processing, so you have to learn all the theoretical aspects that are related to pre-processing. I cannot specifically say whether I'm testing you on that or not testing you on that, but I'm definitely testing you on pre-processing, both the application and the theory behind it, okay? So since it is part and parcel of it, please go through it. Go through the stages, the phases, what happens, how do I apply it on a raw set of data, and so forth. Something similar to what you've experienced in short test and MST. Okay, what do we have then? You have recommender systems. So recommender system, of course, just be mindful, none of the formulas will be given to you. So I'm listing all these as hints. Whatever's listed in here, learn these formulas. You need to know how to apply these formulas. Again, if you go back to 2022 or 2023, you will see that you have questions specifically on recommender systems. So attempt those respective questions and see how it goes for you. Now, while you're attempting these questions, if there's something you don't understand, raise it on the Viber community. For example, you don't understand where did this value come from, for example. Then raise that question. You'll have students who will contribute to it, or I will stop in as well and contribute to it. I'll try my best to be online this weekend to address any queries you have while you are attempting questions as such. Now, again, when it comes to this type of questions, let's take a look at the nature of the data. You will see in here you're making predictions for movie. You are recommending, sorry, not making predictions, you are recommending whether a movie should be watched by a person or not, depending on the previous ratings and ratings of those who are close in proximity to them. So as you can see in here, if we are looking, we have Mary, Megan, and Alicia in here. And again, I am looking at what movies in here. Now, what happens, I will attempt this question and see if I'm able to do it correctly. Then I want to manipulate this question. So I want to change a few things in it. Of course, you can keep it to be movies, that's fine, but let's not only change the values. What students do is they tend to change the values and they think, hey, we've mastered the question. No, you change the number of attributes, very important. And then if you really want to change the question, you tend to change the ratings for what is missing. So if it's movie 4, the value is missing, you manipulate these two. These two should change. And that will give you a different output, a different recommender. So you have to be mindful of that. So again, if we go to 2023, you will see your recommender system was, of course, on a different data set. And what data set we were looking at? You were looking at food. So whether you want to recommend a specific food type or not recommend a food type to a given person. So as you can see in here. Again, same concept. You're just applying the Persian algorithm, right? Correlation, Persian correlation algorithm. That's what you're doing for making this prediction. So go ahead, make an attempt, and if you're facing any difficulties, then of course raise your queries. That's when you start raising your queries. Now again, you'll see that there's some theory questions. You will encounter, of course, theory questions. So when do I apply it? What are the advantages of it? What is the disadvantages of it? How is it considered to be powerful for different scenarios? Scenarios like, for example, in here you can see again, these recommendations, you will see this a lot happening over online transactions, also e-commerce sites or sites where you go to listen to music, watch movies and so forth, or purchasing sites such as Amazon, for example, or where we watch movies, let's say Netflix or Pandora if you're listening to music and so forth. These are recommender systems, right? So is there any specific thing that I need to take into consideration? Can I apply it to a small set of data, or does my data always have to be large? So look into the limitations of it as well. This is again reflected in your notes, advantages and disadvantages of it. And look at the application. If you are unable, someone raised the question about it. So if you're unable to do this question successfully, if you're facing any difficulties, mention what step are you facing difficulties with, and then we can always help. All right, so that's for recommender system. And then you are left with two concepts: web mining and privacy in data mining. Now, both these concepts, if you go through them, your notes are not massive. Your slides are actually quite limited in number for both of them. So you need to read through the entire slide carefully, go through the lecture recordings. I have given out some hints for your final exam while I was conducting those sessions specifically. So I mentioned that you need to concentrate on this. What I mentioned is what you really need to go back and reflect on. So when it comes to web mining, there are different types of web mining. You have content mining, you have structure mining or web structure mining, and you have usage mining, web usage mining, right? You need to know the difference between these three types of mining. Why did we categorize web mining under those three categories? What is the purpose of that? So you need to reinvestigate that. And that's all reflected again in your notes. So what's the difference between, for example, content mining and usage mining? When do I apply? If I give you a data set and I'm asking you what type of web mining you would implement on this given data set, you should be able to determine just by looking at the data set whether it's going to be a content mining, whether it's going to be a structure mining, or whether it's going to be a usage mining, for example. And what is the purpose of content mining? What is the purpose of structure mining? What is the purpose of usage mining? What is the advantages of these? What are the disadvantages of these or the limitations of these minings? Investigate all that. So reflect back on your lecture notes. And then in mining, we also looked at Google search engine, or we looked at the concept of pages, where we said this is an authoritative page, this is a directive page. So you want to go back through that as well. That's another hint I'm giving you. I'll be asking you a question in regards to that as well. Okay, so take a look at that notes. And then privacy, even though the notes might be limited for you in regards to privacy, the topic is massive when it comes to privacy. So when we talk about privacy, of course, whenever you talk about data, you have two concepts, security and then you have privacy. And the ethics that is affiliated with the security of the data and the ethics that's affiliated with the privacy of the data. That's very important as well. So in this, for you to encounter it, you will be given most likely a scenario or a case study. So you will see in 2023, if you look at, again, like I said, you have to go through these papers. If you look here carefully, okay, this is a direct question, this is web mining. But if you look at privacy, you will see that you're given kind of case study. And based on that case study, you're applying your knowledge on what you could potentially do to protect whatever needs to be protected based on the scenario. So again, you will be definitely given a scenario. And based on the scenario, you will need to know how to go about applying privacy measures for data mining and affiliated with ethical measures as well. This is reflective of your note. And what are some of the security measures that could compromise on the privacy of the data as well? So keep that in your thoughts when you are reading through that specific core topic. Okay. You also look at the advantages of privacy in data mining, disadvantages. So if I'm always going to apply or abide by privacy rules, how would that have an impact on my analysis? Am I compromising on my final product output? Am I compromising on the prediction model? What happens if I don't follow it? What are sort of the limitations then in my analysis? Is it considered to be of low quality? Am I compromising on accessing data that I was not privileged to do so? So all that you need to think about it. So when it comes to privacy, it's all about data access privileges because it's privacy. We're looking at privacy, right? But remember, there are ethical issues that are affiliated with it as well. So you want to keep that intact when you are answering questions as well. Be mindful of that. But yeah, it's all about attacking the privacy of the data. So for example, as a student, what is private data for you? Your grades. You wouldn't want to go and be flushing it or flashing it around, especially if they are low. I mean, if they're all A pluses, then yeah, you would like to do that. But if they are not, you would want to be hiding them. So that's private. Imagine we're doing some sort of model prediction on students' performance using your data. And specifically, we of course know your ID, your first name, your last name, and given a scenario as such, what are some of the measures that you would take to ensure that the privacy of a student X is not being compromised? That's just an example I'm giving you. So things for you to think about when you are reading through that set of notes. All right, so that's the hints. Please understand that you also need to read K-mean. So go through an example for K-mean. It was in your lectures, and I've covered one example in your lecture recordings. So please go through that as well. Tell me in a data set or for a scenario, when can I work with multiple linear regression? What are the key components for multiple linear regression? When we have more than one predictor variable. And we cannot say that the predictor it contains continuous variable or it contains, let's say, categorical variable. It does not matter. As long as we have multiple predictors, then potentially we are looking at a multiple linear regression. Good. Tell me, when are you looking at Bayesian regression? When do I know that this is a good technique to use on my data set? When? I thought you did your revision. Single linear when we have one predictor. Binary logistic when we have two possible outcomes. So what about Poisson regression? When your outcome is count. So it's something that we can count. For example, number of seconds, 1 second, 2 seconds, 3 seconds. So it's count. We can count it, right? Minutes, hours. So you're looking at a count. Okay, we'll stop here. Wish you all the very best with your final. While you're revising, don't ask a question like, I don't understand decision trees. You need to be so specific about what exactly you don't understand about it. Else, no one is going to be answering that question for you. Is that clear? Okay, does anyone have any question? Anyone has any question? No, if no one has any question, then I'm ending the session, and I encourage you all, if you have any specific query in regards to application or even theory that you don't seem to understand, you post it directly on your Viber community, as I will be responsive over this weekend. Okay, so I'll look forward to any sort of questions you will encounter or any difficulties you might have during your revision. All the best. Your exam is on Tuesday. Please go through your timetable. Please have it marked on your calendar and set an alarm for it as well. Bye bye and take care.